All right, let's dive into Chapter 6, Section 6.1, and we'll get started talking about composite functions. So, first objective, let's form a composite function, and before we define what it is, let's use an example here. So, suppose that an oil tanker is leaking oil. So here's your tanker, it's leaking oil from here, and we want to be able to determine the area of the circular oil patch around the ship. It's determined that the oil is leaking from the tanker in such a way that the radius of the circular oil patch around the ship is increasing at a rate of 3 feet per minute. So if 60 minutes goes by, I want to know how big this area is. If 2 hours goes by, I want to know how big this area is. And so the problem here is that normally when we have a rate, that's in time. But when we talk about area, that's in terms of pi r squared. I need a formula where I plug time in and area comes out. And so what we're going to do here is we're going to use substitution. We're going to find out area as a function of the rate of time, right? The radius in terms of time. So we're going to plug this in, pi. We're going to substitute because we know r as a function of t is 3t. So everywhere we saw r, we plugged in 3t. So now what do we have? Now we have 9, 3 squared, pi t squared. So if t was 60, I could plug it in and find the area. And what we've just formed here is a composite function where we used one function, r, and plugged it inside of the next function, a. And so what we have here is f composed with g, composite functions, will be written f composed with g here, little circle. This, the second one, is going inside the first one. So g is your input into the f. All right. The domain is the set of all numbers x in the domain of g. So we have to worry about the domain of g such that g of x is in the domain of f. So what we really need to worry about is the domain of g and f of g when we finish. All right, let's take a look here at some of these. We've got f, we've got g. Let's plug g into f. So here's what we're going to do. I'm going to write 2, and everywhere I see x, actually let me start by doing this. F of x equals 2x squared plus 3. Now everywhere I see x, I'm going to plug in the formula for g. So this is 2 4x cubed plus 1 squared plus 3. All right, so we would have to FOIL this and clean this up, right? But for now, let's just leave it like this. The key is what do we plug in where? All right? At this point, it says 1. So this is your composite function, right? And then we're going to plug 1 in wherever we see x of the composite function. So 2 for 1 cubed plus 1 squared plus 3, and let's clean it up. 1 cubed is 1, times 4 is 4, plus 1 is 5, so we've got 2 times 5 squared. 5 squared is 25, times 2 is 50. 50 plus 3 is 53. Let's try this one. Let's write down g. 4x cubed plus 1. Everywhere we see an x, we're going to plug in f. For 2x squared plus 3 cubed plus 1. X turned into the f function. Let's plug in 1 wherever we see the x. 1 squared plus 3 cubed plus 1. So 4 times 1 squared is 1, times 2 is 2, plus 3 is 5. And so we've got 125 times 4 is 500. 500 plus 1 is 501. So you'll see the big difference between f of g of x and g of f of x. What if it's the same letter? That's fine. What's f? 2x squared plus 3. Everywhere we see x, we're going to put in 2x squared plus 3. Squared plus 3. Let's clean it up. Let's plug in a -2. So just be very careful with your parentheses in these problems. -2 squared is 4, times 2 is 8, plus 3 is 11. 11 squared is 121, times 2 is 242, plus 3 is 245. All right, and so we could do the same thing with g of g. In the interest of time, I'll let you go on. Let's try problem 11. All right, objective 2, let's talk about domains of composite functions. So if we were to figure this out, find f of g. So in this case, 2 4x cubed plus 1 squared plus 3. And so at this case, let's clean this up a little bit here. Actually, don't need to, because here's the thing. We remembered two things about domains. You can't have a 0 in the denominator. You can't have a negative square root. Here's what you need to do. Find, since g was the original input, what's the domain of g? That's going to be all real numbers. You also need to look at your final product, the composite. What's the domain of that? Also all real numbers. All right, so compare those together, get rid of anything you can't use, and altogether, our domain would be all real numbers. Let's take a look at one where we wouldn't have all real numbers. So f of g of x, so what we've got here is 1 over. X becomes 4 over x minus 2 plus 4. Let's clean this up. So this will be 1 over, going to need a common denominator, 4 over x minus 2 plus 4, x minus 2 over x minus 2, 1 over 4 plus 4x minus 8, all over x minus 2. Keep going, 1 over negative 4 plus 4x, all over x minus 2. And instead of 1 divided by that, we can multiply by the reciprocal. 1 times x minus 2 over, let's rearrange this, 4x minus 4. And that's just x minus 2 over, pull 1 out, 4x minus 1. All right, so this down at the bottom here is f of g of x. For the domain, what got plugged in? G. What's the domain up here? X cannot equal 2. What's the domain down here? X cannot equal 1. All right, so the final domain would be both of those. X cannot equal 1 or 2. Now notice that we don't care about 4. It's okay to have a negative 4 because negative 4 gets plugged in to g first, and by the time it gets over here, we're okay. All right, so in this problem, x does not equal 1 or 2. Try problem 21. All right, let's try one more. That was a fancy animation here. Let's do f of g on this one. So this is going to be 1 over x. In this case, will turn into the square root of x minus 1. And so we're done there. This is f of g. But what's the domain? So clearly from the end here, x has to be greater. Can't be equal to, just greater than 1 because it's in the denominator. And from the get-go here, from g, we knew that x had to be greater than or equal to 1. So what wins out? X is greater than 1. Let's do f of f. So in this case, it's going to be 1 over x, which is 1 times x over 1, which is just x. All right. X can't be 0. Down here, this is all real numbers. Combine x can't be 0 with all real numbers, and the new domain would be x cannot equal 0. All right, so you're looking for the most exclusive out of the two. Try problems 33 and 35. Okay, now let's prove that two composite functions are equal. So in this one, we have to go both directions. So f of g would be 1/2, plug in g, 2x plus 1 minus 1. G of f is going to be, where's g? 2x is 1/2 x minus 1. Get my parentheses right, plus 1. All right, let's clean both of these up. This is 1/2 of 2x plus 1 minus 1 is just 0, so half of 2x is x. And let's see what we've got here. 2. Let's distribute this first. Half x. Oh, sorry. Didn't see my extra parentheses, so these twos would cancel. So now we have x minus 1 plus 1, and you look at that. We got x, we got x. So these two composites are equal to each other. Try problem 45. All right, now last thing. This is probably the hardest thing for most students. Find the components if we're given the composite. So in this case, f of g is the square root of x squared plus 1. All right, we want to know what the composites are. Now there's a number of ways you can get here, right? But the most common thing is what's going into what. So g is what's going in. So g is going to be the inner. If we look at this, the inner part of this function is x squared plus 1. So I would say g of x is x squared plus 1. Now what's the outer part? The outer part is the square root of something, right? So we're going to say f of x is the square root of something. And those would be your composites, right? The components of your composite function. Let's try one more here. If 1 over 2x squared minus 3 is our composite, what might f and g be? So g is what's going in. So if our input was 2x squared minus 3, we want to get 2x squared minus 3 to be in the denominator. We could say plug it in to 1 over x. And then we would get 1 over 2x squared minus 3. These would be the components of your composite function. All right, so sometimes these are tough to see. Some experience might be necessary here, but give 53 a shot. And that's it. Any questions, we'll go over them in class. Good luck with those problems.